All right, so last set of examples, same idea as before, except this time we might not always get integer answers. So let's go ahead and check those. So again, my suggestion before we even start, let's find the hypotenuse so we don't mess that up. Okay, so across from my angle, the side that does not touch, that's this guy. Right angle, side that does not touch it, that's going to be this one. Right angle, side that doesn't touch it is going to be this one. Okay, so each one of these are going to be my C. Okay, that's how I know. So before I even start, I'm going to make sure I've got that hypotenuse. All right, so as we look at example D here, I've got a 9 squared. The other leg is the x, the one I do not know, and then I've got a 10 squared. All right, so 9 squared is going to give me an 81, plus x squared is going to be equal to 100. The goal is always going to be that x by itself, so let's go ahead and get rid of 81. So 100 minus 81, that should give us a 19. Just like we've been practicing, we got to get x by itself. I'll go ahead and move that down just a little bit more so we can see. Take a square root here. All right, so on the left side, the root and the power undo each other. So x is all by itself, and then we've got the square root of 19. Okay, so the square root of 19, if you punch that on your calculator, it's a decimal. All right, our direction said to simplify the radical. What you're thinking, this is exact form, which means don't give me a decimal. Leave your radical in there. That's what that means. So as I look down here at 19, the question becomes, is there any perfect square that will divide nicely into 19? Right, so 1, okay, but that doesn't help us. 4 doesn't work. Our next one is a 9. Then you've got a 16 and 20. At that 25, it's bigger. So this is our best answer right here. X is going to be equal to the square root of 19. Now, the second I get a side that's got a square root in it, that's no longer an integer value. So as we were kind of talking about that Pythagorean triple, this would not be an example. 9 and 10 were fine, but the square root of 19 is not a nice number. And so this would not be an example of a Pythagorean triple. If we look at example E then, okay, so again, I've got my C out here. So this time I've got 6 squared plus x squared. That's going to be equal to 9 squared. 6 squared should give us a 36. And then on that right side, we should have an 81. X, our goal is always get x by itself. So we're going to go ahead and subtract that 36. And so x squared should be equal to 81 minus a 36 is going to get us a 45. We're going to go ahead and take a square root. Right, so the root and the radical undo each other. So that's why x is all by itself now. Now on that other side, now we've got a square root of 45. Okay, and so our trick is, well, we're going to start dividing it by those perfect squares. Do any of them go in there nicely? So 45 divided by 4 isn't going to work, right? I've got a 5 out here. 5 can't be divided nicely by 4. So then I'm going to try 9. Well, 45 divided by 9 works. So I could rewrite this as the square root of 9 times, the square root of 5. 9 is really the square root of 3 squared, which means my root and my radical undo each other, and so I'm left with the 3. So 3 gets to come to the outside, and 5 has to stay on the inside. So my reduced form, when I simplify the radical, exact form, however they want to ask, it's going to be a 3 root 5. Also, not a Pythagorean triple. As soon as you see a radical in there, it's not going to be a nice number. Okay, so let's look at this last one then. Okay, we've already identified this one's going to be the hypotenuse. So, x squared, plus 5 squared is going to be equal to 10 squared. Sorry, let me fix that. Maybe. Sorry, there we go. Equals. All right, so x squared plus a 25 should be equal to 100. We'll subtract the 25. And so x squared is going to be equal to 75. We'll root both sides. The square root and the square undo each other. They're gone. So x is now equal to the square root of 75. Now, you might remember we've already done this one, right? 75, you're thinking quarters. Okay, so I have 3 quarters that are going to go into there. So I'm going to have a 25 times a 3. Again, it's all multiplication. Okay, so 25 is really the square root of 5 squared. The root and the power undo each other. So I now have a 5 on the outside and a 3 on the inside. So exact form, I'm going to have 5 square roots of 3. So again, none of these were Pythagorean triples because I ended up with radicals in all of them.